नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार दुर्शेट्टी, फैकल्टी ऑफ मेजरमेंट्स। मैं सब लोग को स्वागत कर रहा हूं हमारा यूट्यूब सेशन पर। लेक्चर नंबर 2 है। लास्ट क्लास पे हमने स्टार्ट किया है एरर एनालिसिस से। सो अभी जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए बेटा, ऑडियो वीडियो सब कुछ क्लियर या नहीं। अगर कंफर्म है तो हम स्टार्ट करेंगे फटाफट। ओके, सो लास्ट क्लास में हमने एरर एनालिसिस डिस्कस किया था। एरर एनालिसिस के ऊपर बहुत सारा क्वेश्चंस भी करवाया था। Then today we'll go for the measuring instruments. Okay. So measurements का lecture number चल रहा है. So recap of the previous lecture. So if you see the previous lecture, in previous lecture what we have discussed? We have discussed the error analysis. So what are the topics we have discussed in the previous analysis? एक बार syllabus overview we have taken. सिलेबस ओवरव्यू वी हैव टेकन। देन इसके बाद आफ्टर सिलेबस ओवरव्यू वी हैव स्टार्टेड द एरर एनालिसिस एज अ फर्स्ट टॉपिक। So in error analysis we have seen sum of quantities problems. Next, product of the quantities. Next we have discussed the gate PYQs also. So these are all the topics we have discussed in the last session. So जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए बेटा। खाती सुजाता, गुड मॉर्निंग, कहाँ से हो? गुड मॉर्निंग सुजाता, कहाँ से हो? आर यू फ्रॉम तेलुगु? ओके, चलो now let us move for the topics to be covered today. We'll start the measuring instruments. We'll start the measuring instruments. So under the measuring instruments, we'll discuss the PMMC, okay, construction, उसके बाद वर्किंग, okay, torque expressions. Okay, next, range extension of the ammeter also will discuss. One of the important topic, range extension PMMC. Okay. Next, we'll start the moving iron also. Working, torque expressions, okay. Then we'll discuss the range extension of the moving iron also. Make a note of this list first. Yes, Karnool, AP sir. Okay, Kanpur se. Good morning. So how is your preparation going on? Everything is fine? Okay. BTech completed? Okay. So now let us move for the measuring instruments. So first we will start about the measuring instruments. So we have a big list of measuring instrument. actually. So if you see the torque expressions of the measuring instrument, for gate purpose, you require these expressions. So for gate point of view, you require some table. So I will give you a table. So first to remember the table, most of all the questions are coming from that. Okay. So if you see this, here we are having instrument and it's my deflection torque, is what we call as deflection torque. Instrument, and we call it as deflection torque or deflecting torque. Next comes the TC, controlling torque. Okay, and after this TC or AC and the scale characteristics. Let us see this. Why? Because the single particular box can give you the clarity. Okay, so first let us go for the instrument PMMC. PMMC deflection torque formula, बिना controlling torque formula Kc theta. It is only for DC. Okay, good morning. It is uniform scale. It is a uniform scale. Good morning, Santosh. Please write the comments. Please give the right like buttons. Okay, uniform. Next comes the moving iron. The deflection torque formula 1 by 2 I square dl by d theta, controlling torque formula Kc theta. It is both for DC as well as AC. The scale is non-uniform. Next comes the most important instrument for the electrical measurements, power measurement, that is dynamometer. Dynamometer formula I square dm by d theta. This is Kc theta. It is for both DC as well as AC. So for current measurement it is non-uniform. For voltage measurement it is non-uniform. But for power measurement it is a uniform. Okay, next. The last one is ESVM, which is electrostatic voltmeter. That is 1 by 2 V square DC by d theta. This is Kc theta. It is for DC as well as AC. So non-uniform. Okay, please make a note of these points. Chalo. Now let us move for the first topic, start with the PMMC. So if you see the PMMC, how it works, see, first of all, the total measuring instruments can be classified like this: indicating instruments, recording instruments, and integrating instruments. Okay, measuring instruments का classification कैसा हो सकता है? Indicating instruments, recording instruments, and integrating instruments. So how these indicating instruments will work, how the recording instruments will work, how the integrating, and what are the examples for indicating and recording and integrating. So if you see, for indicating instruments, what is the context? So this is a deflection torque TD and this is a controlling torque TC. Okay, so now if you see, this is a PMMC. So here indicating instruments are working on the base of the pointer mechanism. Okay, so the pointer will be moving left to right. Okay, so इधर क्या हो रहा है ना, wherever the pointer mechanism is there are three torques will be present. एक है deflection torque, एक है controlling torque, एक है damping torque. Okay, so one is a deflection torque, other one is a controlling torque, other one is a damping torque. So the three mechanisms will be there: deflection torque, controlling torque, and damping torque. So they are TD, TC and TD. So इसका example देखो, PMMC is one example, moving iron is example, dynamometer is one example, electrostatic voltmeter one example, thermal instruments are example. जो भी instruments pointer mechanism से काम करता है उसको हम measuring instruments में indicating instruments बोलते हैं. The purpose of indicating instruments बोलो तो indicating instruments will represent only the present value. Indicating instruments will represent the present value. They cannot represent the history. They cannot represent the previous values. Got it? So first of all, you try to share my this particular telegram ID. So जितने लोग लाइव में हैं एक बार ये टेलीग्राम आईडी को शेयर कर दो. So this is my telegram ID. So please scan it and join in my telegram channel so that you can get the regular classes notification. So that is t.me, all letters fine, SCHTISH KUMAR Sathish Kumar sir PW. Okay, so this is my, so please you can type that and you can, that is my channel name, so you can register to that channel. So this is okay, Sathish Kumar sir PW. So that is my title. So all of you please scan this scanner code and join into the particular channel. Okay, give 1 minute time. Noted? Okay. Now we'll move for the topic. See, so these are the instruments, indicating instruments. Indicating instruments will be having the pointer mechanism beta. So please keep a note of that. So they will be having the pointer mechanism. And recording instruments will be having, for a particular moment of time they will record. So examples are CRO, cathode ray oscilloscope. So cathode ray oscilloscope is used for time measurement, frequency measurement, phase measurement. Next, ECG stands for electrocardiogram. Electrocardiogram is a waveform related to the heart pulse. So this is a ECG waveform. So it represents for a particular duration of time. So for a particular duration of time, it will represent the waveform. Okay, na? So these are recording instruments. Next comes the integrating instruments. Integrating instruments goes on accumulation of the values, accumulating the readings, accumulating the reading. So 5 will be there. Next reading will come, 826 will come, next reading comes 827, next reading comes 828. It goes on like that. So the instruments examples for it is energy meter and odometer. Energy meter and odometer. Odometer is for the distance measurement. Okay, so please make a note of this. Integrating instruments. Very good, Chaitra. Okay. So now let us take second classification. This is first classification. Now first of all, before going to that, let us take what are the forces involved. What type of forces are involved? The deflecting force is present. Deflecting force causes the deflecting torque, my dear. Deflecting force causes the deflecting torque. Next comes the controlling force. Controlling force causes the controlling torque. Okay, so deflecting force causes the deflecting torque, controlling force causes the controlling torque. And next comes the damping force. Damping force causes the damping torque. So try to understand what are these three torques. In all pointer based mechanism instrument, these three torques will be present. So deflecting force, what it will do? Deflecting force will be causing the deflecting torque. Okay, so the deflecting force is coming because of the interaction of the current versus flux. So this deflecting force makes the pointer to move to left to right. So it makes the pointer to move to left to right like this. So the pointer mechanism moves left to right. But so according to your current magnitude, the pointer mechanism moves left to right. There is another force called controlling force. This controlling force comes due to spring action, spring force. So controlling torque comes due to spring force. So that is because of the spring action. Whenever this particular pointer moves from left to right, so there should be another force which is upping the pointer to the right, so that at a particular situation the TD is equal to TC, the pointer remains stationary. But it won't come to the stationary point instantly. It will take some oscillations left to right. So it is moving here to here, it is moving here to here. So it will make some oscillations. पूरा oscillations die होने के बाद, then it will settle at the steady state. Okay. So when deflection torque at a steady state, what happens? Actually, to come to steady state, TD is equal to TC, but at that moment the damping torque is equal not equal to 0. So oscillations exist. Oscillations exist. Once the damping torque is equal to 0, it comes to the stationary. So this damping torque is provided with different techniques. Those techniques are eddy current technique and air friction damping technique. Eddy current technique and air friction damping technique. Okay, so these are the three forces that are present. So with this understanding, now we'll go for the PMMC. So this is my PMMC instrument. So PMMC instrument कैसे काम करते हैं देखो. So this is the PMMC. So what is the full form of PMMC? Everybody knows. So what is the PMMC full form मेरे दोस्तों? PMMC का full form बताइए जरा. PMMC stands for what? Permanent magnet moving coil. Am I right? So permanent magnet moving coil mechanism. Permanent magnet moving coil mechanism. That is a PMMC. Okay, chalo, please make a note of this diagram. Good morning. This PMMC, there are two parts. That is permanent magnet. This permanent magnet is done with material 𝐂𝐚𝐿. So that is done with a material 𝐂𝐚𝐿. 𝐂𝐚𝐿 stands for aluminum, nickel, cobalt. Okay. So it provides a permanent magnet, that is B. And next other one is a coil. The coil is made by copper. So this is a copper coil. So the reason for the copper is it is a good conductor. It's a good conductor for the copper. Copper is a good conductor. Next comes the frame. Frame is aluminium. So this is a aluminium frame. So ये है हमारा aluminium frame. So this is aluminium frame. So this aluminium frame is a lightweight frame. Why we are using aluminum? Because the pointer has to move. Next comes the cylinder. Cylinder means ferrous. There is a cylindrical structure here. So this is a cylindrical structure. Cylindrical structure. So this is a cylindrical structure. So these are some structures. Of course, not that much important, but have an idea. Why? Because sometimes one more question can be asked. The cylindrical is made by ferrous because ferrous generates the more radial distribution of the flux. Then इसके बाद springs आ रहे. Okay, the springs are very very important, which will provide the controlling torque. The spring should be wider and it will circle like this. So like this they should move. So now the current passes like this. So it will allow the current. So they're wider in space. They should be conductive and non-magnetic. See, these are the features of the conductive and non-magnetic. They are conductive and non-magnetic. So the current which is passing through that particular spring should not create any external magnetic field. Suppose वो magnetic field create तो already हमारे पास permanent magnetic field है ना, उसको oppose करता है. So that's why the spring should be conductive in nature but should not be magnetic in nature. समझ में आपको? It should be conductive in nature but not magnetic in nature. That's what I'm telling you. It should be conductive in nature but not magnetic in nature. So for that we have a specific material called, what is the material name? The material name is phosphorus bronze. So please note down, on this material also one question was asked once in the GATE examination. So now what happens, as per the Lorentz law, when a current carrying conductor travels like this, so this is a current direction, this is a conductor, this is a magnetic flux direction. So current carrying conductor placed in a transverse magnetic field, then it experiences a force. So according to the direction, so this is a current direction, so this is a current direction I, and this is a magnetic flux direction B, then exerts a force. That force makes this particular pointer, the particular copper coil to deflect. So the force makes the particular copper coil to deflect. So that makes a deflection. So because of the deflection it comes like this. So this is a deflecting force. The deflecting force acts outside. So this is what the B by 2 we can take. So this is a B by 2 width. This is a B by 2. So total is B and this total length is L. So according to Lorentz law force, a current carrying conductor placed in a transverse magnetic field then experiences a force. So because of the force it comes out. So FD is equal to BIL sin theta. Lorentz law force. B is the magnetic flux density, current is the passing through it, L is the length of the conductor, sin theta is the angle between the B and I. So this theta is equal to 90 degrees. समझ में आपको? So now see, there are two forces. Copper coil is this, one force acts like this, another force acts from front to back to front. So the force which is acting from the back, so back force is BL sin theta, and from the front what is the force acting? That is BL sin theta. So the two forces together, so that is 2 BL sin theta. Okay, so theta is equal to 90 degrees, sin 90 is equal to 2 BIL. So it is one for 1 ton coil ये है, for n ton coils it will be 2 BILN. Okay, so is it clear? So this is for n tons coil. So now if you take the deflecting torque, this is a force ना, deflecting torque क्या होगा? Force into perpendicular length होगा. So here comes the perpendicular length. So this is a perpendicular length. So force expression 2 BILN, perpendicular B by 2 gets cancelled. So L into B आएगा बिना. So you can remember this deflection torque formula. The deflection torque formula is Bina. Bina is a Hindi word, like that you can remember. So that's what in the beginning itself I have written here. In the beginning itself, for the purpose of your easy understanding, I have written here. So what is that? You have to remember the formula. बिना. So this is a deflection torque formula. Is it clear मेरे दोस्तों? थोड़ा रेस्पॉन्ड दीजिए भैया, जिंदा हो, जीवन में हो, लाइव में हो. अगर जो भी लाइव में है तो मुझे रेस्पॉन्ड दीजिए, फटाफट क्वेश्चंस के पास जाएंगे. चलो, now we'll go for the controlling torque. How the controlling torque works? So if you see the controlling torque mechanism, so this is a spring force. So spring force, there is a spring na, where is a spring? This is a spring. So when the deflection happens like this, when there is a deflection happening like this, there is a spring force, the spring goes up opposite direction. Okay, the spring goes opposite direction. Yes. Okay. So when the deflection force is acting like this, the spring force opposes in opposite direction. The spring force acts in opposite direction. So the spring force is given by expression. The spring force is given by expression, controlling torque expression Kc theta. So now what happens at steady state? Deflection torque is equal to controlling torque. So bina is equal to Kc theta. So if you equal these two, theta is equal to bina by Kc. So that means this is a relation we are going to get finally. So please make a note of this relation working formula. So what this you understand? Theta is proportional to the current. The deflection is proportional to the current. So now we are going to get the scale. This is a current. This is a current scale, and this is a deflection scale. This is a current and this is a deflection. So the scale is always uniform scale and the linear scale. समझ में आपको? So चलो, these two are the important formulas now. So from these formulas we'll go for the questions. From these formulas we'll go for the questions. Answer this question, madam, fast. Yes. What is the answer? Very simple question. A moving coil of meter has 100 tons. So N is given as 100 tons. Length and depth of this L into given L into B. So from this we can find out the area. 10 into 20 24 minus 6 meters square. Next, uniform radial flux density, that B is given as 200 millitesla. Next, the coil carries a current of I is equal to 50 milliamperes. And the torque on the coil is asking, the deflection torque of formula hoga बिना होगा. So B is equal to 200 into 10 power minus 3. Current is equal to 50 into 10 power minus 3. Okay, number of turns is equal to 100. Next, area of cross section is 10 into 20 into 10 power minus 6. So if you simplify, the answer is going to come as 200 micronewton meter. So formula based questions miss mat karna. चलो, सो ये एक बार नोट कर लो बेटा, फिर से मैं इधर दिया हूं पीएमएमसी के लिए. So we will not go for each and every instrument derivation because in YouTube classes I cannot discuss in entire derivations, waste of time. So आप याद रखने की कोशिश करो, उसके ऊपर डायरेक्टली क्वेश्चंस के पास जाएंगे. एक एक इंस्ट्रूमेंट का एक एक कंस्ट्रक्शन रहता है, कंस्ट्रक्शन के ऊपर एक डेरिवेशन रहता है, वो डिफ्लेक्शन को डिराइव करना है, वो डिफ्लेक्शन टार कंट्रोल पार्ट को यूज करके प्रॉब्लम्स के पास चलना है. दैट्स इट. ऐसा ब्लूप्रिंट बना दो. सो डोंट वेस्ट टाइम ऑन डिराइविंग. गेट इज ऑल अबाउट डूइंग द क्वेश्चंस. आपको कॉन्सेप्चुअल अंडरस्टैंडिंग होना है, कॉन्सेप्ट अंडरस्टैंड होने से आप प्रॉब्लम्स के पास जाना है. सो एक बार ये नोट कर दो बेटा फिर से. पीएमएमसी में फिक्स्ड पार्ट कौन है? परमानेंट मैग्नेट है. मूविंग पार्ट कौन है? कॉपर कॉइल है. उसका एक्सप्रेशन क्या है? डिफ्लेक्शन टार का एक्सप्रेशन बिना है. ओके, नेक्स्ट, मूविंग आयरन का इलेक्ट्रोमैग्नेट है. आयरन पार्ट डिस्किंग है, हाफ आई स्क्वायर डीएल बाई डी थीटा. नेक्स्ट, डायनेमोमीटर में इलेक्ट्रोमैग्नेट है, मूविंग कॉइल है, आई स्क्वायर डीएम बाई डी थीटा. ओके, सो नोट कर दो बेटा, इन ऑल दिस इंस्ट्रूमेंट द टीसी इज इक्वल टू के सी थीटा होगा. Okay, chalo, let us go for based on this. I am giving a question. Try to answer this question. IIT Delhi 2014 का time in the. So please note on the question. Make it fast. see here, this is the PMMC, it's a dynamometer. So for PMMC he has given 100 tons. So N is equal to 100 tons. Flux density B is given as 0.2 Weber per meter square. Coil area 80 mm square. Electrodynamometer has mutual inductance. This is dm by d theta is given. So dm by d theta is given as 0.5 millihenry per degree. So spring constants of this and this both are equal. So here deflection torque is equal to bina, controlling torque is equal to kc theta. So bina is equal to kc theta. So theta is equal to bna by kc, sorry, bna by bina by kc. Am I right? So here deflection torque is equal to I square dm by d theta, controlling torque is equal to kc theta. So theta is equal to I square by kc dm by d theta. So please equal these two, this part and this part equal, you will get the answer as 3.2. Sir, I is equal to 0. No, I will be coming different यार. क्या आंसर कर दिया आपने? हाँ? So here theta is equal to bina by kc, okay na, and here theta is equal to I square by kc dm by d theta, okay va? So we have to equal these two na. So bina by kc is equal to I square by kc dm by d theta. इसको इक्वल करो एंड कैलकुलेट करो. ओके, सो आंसर कितना आएगा? 3.2 एम्पेयर्स आएगा. Yes. चलो. So try to do this question. The right answer to this question is option C. क्या यार लीडर बोर्ड नहीं आ रहा है आपको? यू आर नॉट गेटिंग द लीडर बोर्ड. पोल क्यों नहीं आ रहे? लीडर बोर्ड पर कोई नहीं आ रहे. व्हाट इज द रीजन? आर यू नॉट गेटिंग द पोल? थोड़ा see here. To understand this question, मेरा आवाज आ रहा है clearly? To understand this question, I will go for the range extension. I will go for the range extension. So, if you see the range extension of the PMMC, you will understand this topic. Okay. So, one of the important topic है range extension. उसके ऊपर भी बहुत सारा questions आ चुका है. चलो. So, let me write the range extension of the PMMC. Range extension PMMC. So if you see the PMMC as an ammeter, PMMC as an ammeter, okay. Santosh, are you not getting the poll? See, the range extension of the PMMC कैसे काम करता है? This is what our instrument ammeter. So this is a PMMC ammeter. See the PMMC ammeter. Okay. So here comes this one. This is the IM and this is the RM. And next comes here the shunt component. So to increase the range of the extension, I am giving a shunt. This is the RSH. So here comes ISH. So I is equal to IM plus ISH. IM is the मीटर फुल स्केल करंट. मेरा आवाज क्लियर आ रहा है? एक बार कंफर्मेशन कर दीजिए बेटा. टाइम कम है, बहुत सारे क्वेश्चंस करना है, मुझे कंफर्मेशन कर दीजिए. नेक्स्ट, I is the range to which the current has to be extended. The range to which the current has to be extended. The range to which the current has to be extended. The range to which the current has to be extended. Okay, you try to understand this. So एग्जाम में फॉर्मूलास याद रखने के लिए मैं आपको ट्रिक्स भी देता हूं, फटाफट ट्रिक्स भी देता हूं. So the tricks are also I am going to give. So these tricks will be useful for you. Okay ना? Yeah, these tricks are very very useful for you. So tricks को मिस मत करना. चलो, so this is the I. So now how to write this? These both are parallel na. So this is the voltage here is equal to Vm, and this voltage here is VSH. So here I will tell you. So I will write the Vm is equal to VSH. The voltage across the meter and the voltage across the shunt is same. So Vm is equal to Im into Rm. VSH is equal to ISH into RSH. So from this ISH I have to find, that is Im into Rm divided by RSH. So I need the RSH component. What should be the component of the shunt? The shunt resistance should be smaller so that the maximum current can pass through here. So if I take the RSH, that is Rm into Im. So try to understand the derivation so that in exam अगर आपको फॉर्मूला याद में नहीं है तो आप खुद से फॉर्मूला को डिराइव कर सकते हैं. I don't know information about this. RSH is equal to Im into Rm divided by ISH. So this ISH can be taken as I minus Im. So this can I write Im into Rm. ISH can be taken as I minus. So now RSH can be taken as Im into Rm, the whole divided by, if I take Im out, so that will become as I by Im minus 1. So this gets cancelled. So I am going to get Rm divided by I by Im minus. This I by Im is called multiplying factor, I by Im. So I am taking this as multiplying factor. Okay. So now if I write RSH is equal to Rm by M minus 1. This is the formula. Okay. The same thing, the range extension of the PMMC as a voltmeter, if you see, range extension PMMC voltmeter, if you see, जिंदा हो, जीवन में हो, लाइव में हो, if you see this range, how it works. Very important topic है, वहां से क्वेश्चन आने की चांस है. So this one Rm, this is RSC, this is Im, Vm we can take. So to increase the range extension of the voltmeter, I have to get the voltage. So this particular voltage is V, this particular voltage is Vm. Okay ba? So but the same current is traveling here, series mein hai na, this current and this current same. So V, if I take, I can take the total current I, this resistance RSC plus Rm hoga. But whereas Vm if I take, that will be केवल Im into Rm होगा. So if I take the ratio, जिंदा हो, जीवन में हो सब लोग, So here गेट एग्जाम के लिए, गेट एग्जाम के लिए बहुत सारे बच्चे क्या करते हैं ना, वो पढ़ाते हैं, बहुत सारा बुक्स पढ़ते हैं, टाइम को मैनेज करने के लिए बहुत सारा पढ़ते हैं, बहुत सारा पढ़ते हैं। लेकिन आपको ये याद रखना है गेट में क्या पूछते हैं। गेट में केवल सर्टेन टॉपिक्स पर न्यूमेरिकल क्वेश्चंस आ रहे हैं, उसको पहले कंप्लीट करना है। उसको पहले कंप्लीट करने के लिए कुछ ना कुछ स्मार्ट वर्क करना है, नोट्स मेंटेन करना है, शॉर्ट नोट्स लिखना है, वो शॉर्ट नोट्स को आप स्निपेट्स की तरफ से स्टोर करना है। ये दिस ऑल टेक्स अ मंथ्स एंड मंथ्स ऑफ प्रिपरेशन, एक दिन में नहीं होगा। कंपेरेटिवली लास्ट 5 इयर्स, अभी प्रेजेंट जनरेशन को ये एडवांटेज है। क्या है ये एडवांटेज? बहुत सारा कंटेंट यूट्यूब पर मिल रहे, बहुत सारा बेस्ट ऑफ द फैकल्टीज यूट्यूब में पढ़ा रहे। सो वो आप देख के आप एक शॉर्ट नोट्स बनाना है। सो जस्ट लाइक दैट आई एम गिविंग अ शॉर्ट नोट्स, सो दिस शॉर्ट नोट्स यू हैव टू मेक अवेलेबल इन योर स्मार्ट रूम। देयर शुड बी सेपरेट स्टडी रूम फॉर यू। आपके लिए एक सेपरेट स्टडी रूम बनना है। अगर आपके घर में एक स्मॉल रूम है तो बोर्ड लगाओ, डोर क्लोज करो, पूरा वॉल्स पर स्टिकर्स बनाओ, लाइट बनाओ, सोशल मीडिया डिस्ट्रैक्ट बनाओ, आपका सिस्टम पे इंस्टाग्राम, फेसबुक सब कुछ रिमूव करो, ओनली कंटेंट शुड बी देयर, डोंट डिस्टर्ब लगाओ। अगर वो रूम में चले तो 4 घंटे तक बाहर नहीं जाना, 4 घंटे तक आप नोट्स प्रिपेयर करते जाओ। सो हाउ टू प्रिपेयर द नोट्स, दैट इज ऑल्सो स्मार्ट वर्क। सो प्लीज नो नीड टू राइट द एंटायर थिंग, आपको क्वालिटी होना है। देखो अगर ये अमीटर देखो, अमीटर में ये पर्टिकुलर शंट रेसिस्टेंस पैरेलल में है, अमीटर को शंट रेसिस्टेंस पैरेलल में है, सो दैट्स व्हाई द m केम इन द डाउन। रेसिस्टर नीचे है, m केम इन द डाउन। बट इफ यू सी हियर फॉर सीरीज व्हाट हैपेंस, इफ आई टेक द डेरिवेशन v by vm is equal to this is I into rsc plus rm the whole divided by im into rm। ये सीरीज में है ना, सो दिस करंट एंड दिस करंट दोनों सेम है। अगर सेम है तो ये खत्म, कैंसिल हो जाएगा। इफ आई टेक दिस मल्टीप्लाइंग फैक्टर एज वोल्टेज मल्टीप्लाइंग फैक्टर एज vm and this is rsc plus rm, सेपरेट करो, दिस 1 होगा। सो फ्रॉम दिस इफ यू सी rsc by rm -1, m -1 होगा। सो यहां से आप सीरीज रेसिस्टर को देखो, rsc इज इक्वल टू rm इंटू m -1 होगा। अभी देखो ये पूरा डेरिवेशन को आपका जरूरत नहीं है, आपको ये फाइनल जो फॉर्मूला है ना, फाइनल जो फॉर्मूला है, दैट फॉर्मूला यू हैव टू मेक इट नोट। सो अमीटर के लिए ये शंट कंपोनेंट नीचे आ गया, इसके लिए m -1 नीचे आ गया फॉर्मूला में, एंड यहां सीरीज में आ गया, यहां सीरीज में आ गया। देखा, समझ में आया ये ट्रिक? समझ में आपको? फॉर वोल्ट मीटर m -1 कम्स इन सीरीज, फॉर अमीटर m -1 कम्स एट द बॉटम, बिकॉज अमीटर के लिए शंट नीचे होगा, वोल्ट मीटर के लिए सीरीज में होगा। अगर आपको ये ट्रिक समझ में आया तो मुझे एक थम्स अप दिखाइए। जैसा ट्रिक्स है, एक एक सब्जेक्ट में बहुत सारा ट्रिक्स रहता है, वो ट्रिक्स देख के आपको प्रॉब्लम को सॉल्व करो। मैं फिर से ये प्रॉब्लम आपको दे रहा हूं, सो फिर से ये प्रॉब्लम आपको दे रहा हूं, ट्राई टू सी दिस। सो व्हाई यू आर अटेंडिंग द यूट्यूब सेशंस, यूट्यूब सेशंस में आपको पोल रहता है, वो पोल देख के आप आंसर कर सकते हैं। मल्टीपल चॉइस क्वेश्चंस में दिया हूं, सो प्लीज इन्वॉल्व इन द पोल एंड स्टार्ट द पोल। आई एम गिविंग द टाइम, दिस टाइम फैक्टर ऑल्सो वेरी वेरी इंपॉर्टेंट मेरे दोस्तों, दिस टाइम फैक्टर ऑल्सो वेरी वेरी इंपॉर्टेंट। आपको ये टाइम प्रैक्टिस करना है। बहुत सारे बच्चे टेक्स्ट बुक देख के प्रॉब्लम्स करते जाते, लेकिन गेट का एक्सपीरियंस अलग है। गेट लैक्स ऑफ पीपल आर राइटिंग द एग्जाम। In that exam, if you want to succeed within the specified time, you have to solve the 80 questions or 100 questions. So you should have a limit for each question. एक एक क्वेश्चन के लिए लिमिट होना है, 45 सेकंड 60 सेकंड के अंदर करना है। उसको क्वेश्चन को आप 2 मिनट में भी कर सकते हैं, 5 मिनट में भी कर सकते हैं, लेकिन गेट इज ऑल अबाउट द टाइम बेटा। यू अंडरस्टैंड? या इट्स 25 ohms sir, but I am talking about the time management. Time management is very very important. So option C is the right answer. लीडर बोर्ड पर कोई नहीं है, आई थिंक इट्स टेकिंग सम टाइम। ओके, लीडर बोर्ड पर कोई नहीं आ रहे, वाई द लीडर बोर्ड पर कोई नहीं आ रहे, आर यू नॉट गेटिंग द लीडर बोर्ड? ओके, चल लीडर बोर्ड पर पार्टिसिपेट करो, आर यू नॉट गेटिंग द लीडर बोर्ड मेरे दोस्तों, लीडर बोर्ड पर पार्टिसिपेट करो. सो हियर what is given 100 microamp. First in the question ammeter is given. Once the ammeter is given, draw the diagram like this. So this is IM draw करो, this is RM draw करो. ammeter के लिए शंट रेजिस्टेंस पैरेलल में आएगा, इधर RSH ड्रा करो. So ये है I, ये है ISH. That's it. अभी क्वेश्चन में फटाफट क्या डाटा दिया है, 100 माइक्रो एम्पियर्स ammeter. So this is 100 माइक्रो एम्पियर्स ड्रा करो इधर. And meter resistance is 100 ohms ड्रा करो. For extending range to measure 500 microamperes, either 500 microamperes draw karo, and is asking the shunt resistance. So what is the formula? RSH is equal to ammeter. Ammeter के लिए m-1 नीचे आएगा. That's it. RM. m बोले तो क्या है? I by IM-1. I am telling you the trick बेटा. वो ट्रिक को आप याद करके एग्जाम में यूज करो. RM is equal to 100 है. I is equal to full scale current, that is 500 micro. IM is equal to 100 micro. फटाफट -1. Don't neglect this -1. Sometimes it matters. 5 - 1 4. So answer कितना आ रहा है? 25 ohms. So the right answer is option C. Option C is the right answer. Let us go for the next question. Try to answer this question. Try to answer this question. IIT कानपुर 2015 का साल है. अगर एक बार आपको कॉन्सेप्ट मिला, वो कॉन्सेप्ट के ऊपर लास्ट 25 साल से, लास्ट 15 साल से जो गेट क्वेश्चंस आ गए उसको प्रैक्टिस करना है. So that's how your concept will become strong. एक बार पढ़ा है, कॉन्सेप्ट को समझ गया, देन इमीडिएटली ओपन द पीवाईक्यू सीरीज. गेट में जो जो पीवाईक्यूज है वो पीवाईक्यूज प्रैक्टिस करते जाओ. दैट्स इट. ओके, सो आई एम गिविंग द पोल फॉर दिस इंटीजर टाइप क्वेश्चन. 60 सेकंड्स का टाइम दे रहा हूं. स्टार्ट में पोल करो. तो लीडर बोर्ड पर कोई नहीं आ रहा है, मुझे समझ नहीं आ रहा है वाई द लीडर बोर्ड पर कोई नहीं आ रहा है. ओके, इंटीजर टाइप, स्टार्ट द पोल, मेक इट फास्ट. आंसर क्या है? सी. क्वेश्चन में क्या दिया है? अम्मीटर. ओके, सो अम्मीटर का डायग्राम ड्रा करो. सो दिस इज IM, दिस इज RM. सो 0 to 50 amperes. So this will be 50 amperes. As a voltage drop of 0.1 volt. So this voltage drop is given as 0.1 volt. So RM is not given. Across its terminals, the external shunt resistance is asking. So he is asking the external shunt resistance. This is RSH and this is the I. So you want to extend the range to find. So question में जो value bigger है that will be the full range. जो value smaller है that is a meter range. Okay. So again the same formula. RSH is equal to RM by M-1. RM divided by I by IM minus 1. So what is a meter resistance here? We don't know. Meter resistance के लिए हम ये formula use कर सकते हैं ना VM का. So VM is equal to IM into RM use कर सकते हैं ना. VM is equal to IM into RM. So this is 0.1 volt. So meter current 50 amperes into Rm. So Rm is equal to 0.1 by 50 అంటే 1 by 500. 1 by 500 means 2 milliohms. Am I right? 2 milliohms. So this is 2 milliohms, 2 into 10 power minus 3. I is equal to 500. Im is equal to 50. minus 1 को neglect मत करो. 10 minus 1 9. So 2 by 9 into 10 power minus 3 ohms. So 2 by 9 बोले तो कितना आएगा शंट यूज करके पता. Nobody has done the right answer. So it is coming 0.222. So the right answer is 0.222 milliohms. So question में दिया है in milliohms 0.222 you have to write. Oh sorry, it is a so leave it. I have given as a integer type. So 0.222 milliohms. All have written. All after getting the pole material. Whoever are there in the live, you can answer that. Chalo, let us go for some more good questions. Answer this question, make it fast. Average 85 volts. Correct answer is V. What is happening here? Poll में आप please can anybody reply me? Are you not getting the poll over there? You are not able to answer by poll. You are not using poll. Are you watching on the YouTube web or what? मोबाइल ऐप में यूज करो तो आपको मोबाइल ऐप यूज करो ना, मोबाइल ऐप यूज करो तो आपको वेब पर आ जाएगा. तो YouTube में पोल्स भी आ रहे हैं. दिस पोल्स विल बी इंटरेस्टिंग सो दैट यू कैन गेट द टाइम अवेयरनेस. ओके, चलो लेट अस सी हियर. First of all, this is a pulse. So high is this, low is this. So first we have to get the average. Why? Because PMMC is not suitable for AC measurement. PMMC is suitable only for DC measurement. So what is the I average? So I average, I can take it as 12 plus 5 divided by 2. So this is what happens, 17 by 2. So this is the 8.5 amperes. 8.5 amperes. So that is 8.5 amperes. So now DC voltage क्या होगा? DC voltage means this a voltage here ना. So this current is passing. So the parallel voltage is asking. So current into resistance. So current is a DC current and the resistance. That is how much current we got? 8.5 amperes into resistance is 10. So answer is 85 volts. So 85 volts is the right answer. Okay, let us go for the next question. So try to answer this question. सेवन स्टूडेंट्स लाइव में है बट मुझे पोल पर नहीं दिख रहे हैं, क्या हो रहा है? इसका आंसर क्या है? 0. यस, अभी आ गया लीडर बोर्ड पर रोहित सिंह बोल के. ओके, अभी लीडर बोर्ड पर रोहित सिंह बोल के एक आदमी आ गया. ऐसा लीडर बोर्ड पर आ जाओ यार. सो यू प्लीज पार्टिसिपेट इन द लीडर बोर्ड. ऑप्शन डी है. ओके, सो व्हाट इज मेंशनिंग? द स्प्रिंग विल बी लाइक दिस ना बेटा. द स्प्रिंग विल बी लाइक दिस. दिस इज अ स्पिंडल. सो दिस इज आवर कॉपर कॉइल and here comes our spring. So the current is going like this. So what is mentioning here? A 0 to 10 milliamperes current. So this is 0 to 10 milliampere जा रहा है यहाँ से source से. Reads 4 milliamperes in a circuit. In its bottom control spring snaps suddenly. Bottom control snap हो गया. That means cut हो गया. Cut होने की वजह से current नहीं जा रहा है. Current will be 0. So then the deflection will be 0. The deflection will be at 0 only. The deflection will not go to 4 and the deflection will not go to 10. Anyway, the circuit has become 0 because the current cannot pass through. So I is equal to 0. So let us go for the next question. Answer this question. मैं पोल दे रहा हूं आपको, पोल पर अटेंड करो. Yes. What is the answer here? Answer is option C. लीडरबोर्ड पर कोई नहीं आए. What's happening? लीडरबोर्ड पर कोई नहीं आए. So question is related to galvanometer with a full scale current of 10 milliamperes as a resistance of 1000 ohms. As a resistance of 1000 ohms. The multiplying factor he is asking. So 100 ohms shunt with a galvanometer is dash. Okay, a galvanometer with a full scale current of 10 milliamperes has a resistance of 1000 ohms. So he is asking the multiplying factor for the current, right? Current. Okay, so let me take the expression. Whenever question is asked, better to go with the diagram. So this is the RSH, this is the IM, this is the I, this is the ISH. Okay, a galvanometer with a full scale current of 10 milliamperes. So this is 10 milliamperes. As a resistance of 1000 ohms, the meter resistance is 1000 ohms. The multiplying factor 100 ohms is a shunt resistance. So M is asking. So RSH का formula use कर सकते हैं directly. RSH is given 100, RM is given 1000. Very simple question. Multiplying factor is asking M. So M minus 1 is equal to 10. M is equal to 10 plus 1, that is 11. Option C. Yes, let us go for the next question. Make it fast. The scale of voltmeter is uniform. The right answer here is option C. Very good question. वीडियो पर कोई नहीं आ रहे हैं. Theta is proportional to I square. Induction also theta is proportional to I square. Moving coil theta is proportional to I. Dynamometer theta is proportional to I. So this particular scale only uniform. Remaining all scales are not uniform. So option C is the right answer. So let us go for another question. Answer this question. answer for this question here is 150 volts. How many of you got it? Nobody has given the right answer. Are you not getting the leaderboard? See here. What is asking? 200 volts full scale PMMC type DC voltmeter having figure of merit of. So what is first of all figure of merit? Figure of merit is equal to 10 kilo ohms per volt. This is a sensitivity. To represent 1 volt, it needs an internal resistance of 10 kilo ohms. So full scale value is 100 volts. So full scale value 100 volts means it represents 1000 kilo ohms. RM. Okay na? So this one figure of merit here is 20 kilo ohms per volt. So for 1 volt it is showing 20 kilo ohms. For 100 volts full scale, 100 volts full scale, it represents how much? 2000 kilo ohms. So now both are connected in series. So if you take the inverse, this is also called as sensitivity. So this is also called as sensitivity. So if you take 1 by S1, what I am going to get? So 1 by 10 kilo ohms per volt, that is 1 by 10, 0.1 milliampere. This is the full scale deflection current for the first one. That means what is the full scale deflection current for this particular ammeter, sorry, this voltmeter, so that it can show a full scale voltage of 100 volts. So that is 0.1 milliampere. And its internal resistance of this meter is how much? 1000 kilo ohms. Next, here figure of merit is given. So 1 by sensitivity करे तो कितना आएगा? 1 by 20 kilo ohms per volt. 1 by 22 means 0.5. So this is 0.05 milliampere. Okay, so that means the full scale deflection current 2 is equal to 0.05 milliampere. Okay, so now if I am going to check this full scale deflection current to 2, so it requires 0.05 milliamperes to give a full scale voltage of 100 volts, but here the resistance is 2000 kilo ohms. Now both are connected in series. When both are connected in series, what happens? Agar both are connected in series, the net resistance will become as 3000 kilo ohms or series. And which current will connect? When both the voltmeters are connected, to get the full scale deflection, whichever current is giving the least current, that will take. So 0.05 milliampere. So then what is the voltage? So 0.05 into 10 power minus 3 into 3000 into 10 power 3. So 10 power 3, let's cancel. So answer is 150 volts. Right answer कितना है? 150. Done? Any doubts? Okay, enough for today बेटा. नेक्स्ट क्लास में हम मूविंग आयरन के बारे में डिस्कस करेंगे. सो यहाँ तक हमने जो जो डिस्कस किया दैट बस है. आप थोड़ा इफ यू हैव एनी डाउट्स यू कैन आस्क मी. आज के लिए बस है.